wave. So a stationary wave is a wave which does not transfer any energy. That means theoretically it still does move, but it doesn't actually transfer any energy. These stationary waves are measured in harmonics. So for example, the first harmonic looks like this. So there are 2 points, and then there's one wave going this way. It bounces back off this post and it comes back the other way. So this is the first harmonic. So the first harmonic is basically a half a wavelength which has one antinode and 2 nodes. Nodes are basically a point with no displacement, and an antinode a point with maximum displacement. So one normal wave looks like this. So, well, not like that, but like that. So that's what a normal wave looks like. So if you look at the first harmonic and you look at this wave, you can see that the first harmonic is exactly half. So if we split this through here, half of the whole wave. That means theoretically that this first harmonic is half lambda, or half a wavelength. So to work out the full wavelength, it is basically 2 times L, where L being the actual length of the wave. And the frequency of this, well, the normal wave speed equation is wave speed equals wavelength times frequency. So if we were to rearrange that, frequency equals wavelength over wave speed. So in this case, frequency would be 2 times the length over the wave speed. Or obviously the other, frequency equals 1 over period, or time period, which could also be 1. But that is basically the first harmonic. It is a wave which doesn't actually transfer any energy. It still does move up and down. So say if you had a particle, a object here, it would move this way and that way. So it would move up and down, but only up and down. It would never move, we should use a red for this. It would never move this way or this way. So it can only move up and down. That's because the wave kind of does this motion, but doesn't actually move. So nodes, antinodes, the actual wave, formula around the wave. Now wave practical. So the first harmonic practical is frequency equals 1 over 2L root T over mu, where mu is the mass over length. So basically what this is the formula to work out the frequency of the first harmonic, where this is actually the frequency, L is the length of the wire, tension is the mass times 9.81, which is the force due to gravity, and mu is obviously mass over length. So there are actually 3 ways of doing this experiment. Well, this will be your first practical, which will be the length of wire with the tension and the mass of wire. So these will either, well, one of these, I've written one twice, will be your independent variable. So one of these will be the thing that you change. So say if you are changing tension, you add mass. So you add mass to the bottom of the experiment basically, and that will change the tension. But in that case you keep length of wire and mass of wire constant. Then there is a length, just change length. And finally there is the mass of the wire, and to change the mass you just change the material of the wire. But say you had X material, you could keep the same like length of the wire, but obviously because it's a different material, weight different. Because the weight is different, overall that will mean that it is better. So I have bare notes, you know. There are probably like neater variants of these notes that I can find from somewhere. That, there we go. This is the stationary wave, and it's overall all the stuff that you need to know about it. Peace.